Hello! In this video we will discuss how to choose the correct motor for your project. We will take a look at motor specifications and the differences between DC, servo and stepper motors. Let's start with the specifications. There are quite many things to take into account, but we will highlight the most important ones. Of these, the first you will have to think about is the speed and torque of the motor. The speed in datasheets is usually for when there is no load on the motor. The speed is expressed as revolutions per minute, RPM for short. The torque is expressed as Newton meters or more often as kilogram centimeters. The torque tells how much weight or force the motor can output at a specific distance from the shaft. If you want more torque and can sacrifice speed, we recommend looking into gearing and gearboxes. Next, the current requirements. Motors are commonly rated for a specific voltage range. Going above the maximum value will probably break the motor. The current draw is separated at least to stall and no load currents. Stall current means that the load is so large that the motor can't rotate the shaft. Lastly, we need to take into account the dimensions, weight, as well as the operating life. Operating life can vary a lot depending on the motor type. For example, for brushed or brushless DC motors. Next, we'll look at the differences between DC, servo, and stepper motors. The discussed motor properties are only indicative, as there might be large differences between models. That said, let's jump into it. First, the rotation restrictions, speed control, and position control. A DC motor offers continuous rotation, which is easily adjustable with a PWM signal. However, it lacks position control. Servo motors are restricted, usually to a 180-degree rotation angle. With the Arduino standard library, they have a set speed, but other libraries allow for variable speed control. Servos allow for great position control within their limits. A continuous servo sacrifices the position control for continuous rotation and speed control. Stepper motors rotate continuously, allow speed control, and have very precise position control. The rotation smoothness depends on the resolution of the stepper motor. Note that the stepper motor can maintain its position and will counteract external forces. Next, the speed and torque. As a rule of thumb for all motor types, there is a trade-off between speed and torque. Low speeds equal high torque, high speeds equal low torque. DC motors can reach speeds over 10,000 RPM, however, they usually offer low torque. Normal and continuous servo motors generally run at 3,000 to 5,000 RPM, and thanks to the gearing, they offer high torque even at high speeds. Steppers are slow motors but offer great torque at low speeds. Note that the current draw of motors scales in most cases with the amount of load put on them. The stepper motor is an exception, as it draws the maximum current even when staying still. Lastly, the control complexity and need for additional circuitry. DC motors are easily controlled with a PWM signal, and they only need additional circuitry if you want to change the direction of rotation. In that case, you need an H-bridge or a motor driver. Servo motors are also easy to control with the Arduino library, and the circuitry they need is already built into them. With stepper motors, we recommend using a motor driver, as it simplifies the control and circuitry a lot. Without a driver, it can be a bit tricky to get the stepper to work as wanted. Next, some example use cases for the motors. DC motors are used in applications where high rotation speeds are required. For For example, radio-controlled car wheels and drone rotors. Servo motors are used when small trajectories are enough. For example, robot arms, claw mechanism, and pushing movements. Stepper motors offer high precision and control. They are used in precise control arm movements, for example, 3D printers. That's everything for this video. Thank you for watching and see you in the next one.